This is the fourth section of a four-section module on centrifugal pump principles. This section covers classification of centrifugal pumps. All centrifugal pumps operate on the same principles, regardless of the actual work they do, whether it's low to high pressure pumping, moving light to heavy fluids, pumping small to large volumes, or whatever. What distinguishes one pump from another is size, shape, and basic design. Design is most important. Shafts in vertical pumps are perpendicular to the ground. The driver is usually positioned above the pump. Shafts are parallel to the ground in horizontal pumps. The driver is usually positioned beside the pump. Two other important terms are overhung and between bearings. They refer to the position of the impeller in relation to the bearings. In overhung pumps, the bearings are located on one side of the impeller. In between bearings pumps, the bearings are located on both sides of the impeller. In single suction impellers, fluid enters the impeller only through one side. In double suction impellers, there's a suction eye on both sides of the impeller. Fluid enters the pump through a single intake port, but it's then directed toward both sides of the impeller. You already know about single and multi-stage pumps. The number of impellers is the distinction here. Obviously, single-stage pumps have only one impeller. Just as clearly, multi-stage pumps have two or more impellers in series on the same shaft. The purpose of multiple impellers, as we learned earlier, is to produce higher discharge pressures than is normally possible with just one impeller. Volute and diffuser are also terms you now know. They describe the area in the centrifugal pump casing where the kinetic energy of the fluid is converted into pressure. In volute pumps, the casing forms a chamber, or a volute, that's wider at the discharge port than where the fluid leaves the impeller. In diffuser pumps, instead of a volute, there's a diffuser with stationary vanes that form a series of widening chambers. A couple of terms used to classify centrifugal pumps that we haven't covered yet are radial flow and axial flow. In radial flow pumps, the impeller is designed to direct the fluid out at a 90-degree angle from the shaft. In axial flow pumps, the path is parallel to the shaft. Strictly speaking, axial flow pumps aren't centrifugal because they don't use centrifugal force to add energy to the fluid or to convert the velocity of the fluid to pressure. Axial flow or turbine-type pumps are nevertheless frequently classified with centrifugal pumps because their parts and maintenance requirements are similar. Example: a vertical overhung single suction, single stage radial flow volute pump with a closed impeller. That's one centrifugal pump. Another one is this one: a horizontal between bearings, single suction multi-stage radial flow volute pump with closed impellers.